To wrap up this video, here are a few comments on implementing type checking in the presence of self-type. First of all, the extended subtyping and least upper bound operations can do a lot of the work. If you extend subtyping and least upper bound in the way that we did, then a lot of the rules don't have to change, and for the most part, you don't have to do anything special for self-type. Self-type can only be used in a very few places in the language, and it's up to you to check that it isn't used anywhere else. Those restrictions have to be followed carefully. And finally, for the most part, a use of self-type always refers to any subtype of the current class. There is one exception to this in the type checking of dispatch. In dispatch, there's a method lookup where we look up in some class C a method F, and it's possible that that method will have a return type self-type. And this class here, C, may have nothing to do with the current class. We're dispatching here to a different class, and whatever our current class is, this particular self-type refers to self-type in that class, the class in which we're doing the lookup, not whatever class in which we're doing type checking. And fortunately, we never need to compare that self-type to any self-type in the current class, so there's no crosstalk between different kinds of self-type. And again, this is the only place in the type checking rules where you look at a self-type that is not one in the current class. To summarize our discussion of self-type, self-type is still a research idea. It adds more expressiveness to the type system, and I think that's easy to see, but you won't find self-type in mainstream languages. Self-type by itself, I think, is not so important, except for the project that you're going to implement. Rather, the reason for including self-type is to illustrate that type checking can be quite subtle. It's not all int plus int equals int. There actually are fairly sophisticated things and fairly sophisticated reasoning that goes on inside of type checking. In practice, of course, there needs to be a balance between the complexity of the type system and its expressiveness. More complex type systems are harder to learn and they're harder to use effectively, but they also allow you to write more programs.